Okay, so we're going to prove something that we actually noticed in the previous video. Let's actually scroll up here for a second before we prove that. We saw, where is it? Ah, here it is. We saw that this equality right here, so plus or minus 1z is equal to z. And that was interesting. It's interesting, and we're going to try to generalize it. So what happens is on the left-hand side, we have an ideal. Why? Because we showed it in several different ways. And in particular, on the left-hand side, we know some things. We know that 1, well, both plus or minus 1 are in plus or minus 1z, irrelevant of if we're taking plus z or negative z. So let me actually write that a little bit differently. We know plus or minus 1 is in 1z, and plus or minus 1 is in negative 1z. Why? Well, you can, there's certainly a, plus or minus 1 is certainly a multiple of 1 or negative 1. And so we saw that these sets have a unit in them. Namely, they have 1 or negative 1. That, in fact, they have both, but they have a unit. And having a unit actually tells us that the ideal must be the whole ring. And so that's what we're going to prove in this theorem. Let's scroll back down. So suppose you have a ring, an ideal of R, then I is all of R if and only if I contains a unit. Let's do the forward direction. Well, if I equals R, then 1 is in R, but R is equal to I, so 1 is in I, and 1 is a unit. Okay, so I contains a unit. Great. Suppose that I contains a unit. For the backwards direction, we have to show that I equals all of R. Let's say that we have some unit U is in I. Then, since it's a unit, there exists some V in R such that VU is 1. But I absorbs multiplication by R. So VU, which is 1, U is in I. This guy is in I. And so the product is also in I. Thus, 1 is in I. Now take any element of your ring. Then R is R times 1, but 1 is in I. So R times 1 is also in I. So any element of your ring is in the ideal. But let me say, since, well, certainly I is an ideal of R, so I is a subset of R, we get that R has to be a subset of I, and so I equals R. Okay, so again, this is the fact that we saw, and I want to highlight it. So if your ideal contains a unit, something with a multiplicative inverse, you have to be everything. And it's a, it's not a super important fact, but it is a helpful fact.